microwave tubes, and this is a reflex klystron tube. It is different from the conventional tubes. The conventional microwave tubes are having some limitations and losses. The first one is a interelectrode capacitance, second one is a lead inductance effect, and third one is a transit time effect, fourth one is gain bandwidth limitation, and fifth one is effect of RF losses, and sixth one is effect due to radiation losses. Now coming to the interelectrode capacitance. A tube structure is having some three electrodes, name it as anode, cathode and grid. Anode and cathode and grid. So these two, anode is made with positive with respect to cathode, cathode is a negative. So if a positive plate and negative plate separate by some dielectric, then it is having some capacitance effect called as a interelectrode capacitance, anode and cathode. CAK is a one capacitance called as a interelectrode capacitance between anode and cathode. Why? Because the anode is positive plate and cathode is a negative plate separated by a dielectric, so it is having the capacitance effect called as a capacitance CAK between the anode and cathode. And next one is the grid is negative with respect to anode, therefore a capacitance existing between the anode and the grid. Why? Because the definition of capacitance says that a parallel plates, positive and negative plates, opposite polarities and separated by a dielectric is equivalent to the capacitance. Therefore, the anode is positive with respect to grid. Therefore, a capacitance existing between CGA, capacitance between grid and anode. Similarly, coming to this with respect to cathode, grid is positive. Therefore, one more capacitance existing between cathode and grid called as a CGK. And these three are called as a interelectrode capacitances. So if these are existing in this tube structure, then what is the effect of these capacitances at higher frequencies, that too at microwave frequencies? Coming to the frequency, that is XC is a capacitive reactance, that is 1 by j omega c, which is equal to 1 by j 2 pi fc. At microwave frequencies, the frequency is in the order of gigahertz. Therefore, X is very low, very low. So therefore, the capacitance reactance is low in the sense of the resistance part in this anode, grid and cathode is very low. This turns to make a short circuit between the anode, cathode and grid at higher frequencies. Why? Because at higher frequency of gigahertz of frequency, the capacitive reactance Xc is very low, approximately 0. Therefore, it is make a short if you use these tubes at gigahertz of frequency. This is therefore the conventional tubes are not at all used at microwave frequencies. A lead inductance effect, that is nothing but any terminal in this tubes, anode having one lead, grid is having one more lead and cathode is having one more lead. So if the lead is having some inductance, why? Because a lumped circuit, a lumped line is replaced with the inductance. So having the cathode inductance LK and grid inductance LG and anode inductance LE. So if this inductance is there in the tubes at the leads, then what is the effect of this effect of lead inductance at high frequencies? Coming to this XL equivalent to j omega L, that is the inductive reactance equal to j omega L. So at higher frequencies, why? Because at gigahertz of frequencies, the XL is also high. XL is also high, nothing but similar to a open circuit. XL is high, similar to a open circuit. So if the lead inductance is more at higher frequencies, then this will make a open circuit. Why? Because XL at higher frequency, the inductive reactance XL is high, then it will make you open circuit, or If R is high, if inductance R is high, the voltage drop is high. Similar to a open circuit, the V voltage is maximum. Therefore, if you apply the input voltage between any of the lead, and for example, take here I am applying at cathode 10 ohms here, and because of this XL inductive reactance at lead will make the maximum voltage drop. It takes 9 ohms drop, only 1 volt is going to this cathode. So it is not into the input. You are applying the input at 10 ohms, but it takes only the 1 volt. Why? Because maximum drop existing at the 9 ohms at the lead because of this lead inductance. Why? Because this lead inductance is having the high resistive part, high resistance, though the voltage drop is also more. So similarly, if you want to take output at this grid, but you require a 10 ohms output, but the drop at the lead will make you take 9 ohms, you get only the 1 volt drop. So with the high input resistance or high resistance at the lead, why? Because inductive reactance is more at higher frequency, the resistance is more at leads, and will cause that if you want to apply input, it takes only drops higher voltages at the input. Similarly, if you want to take output, it takes output voltage drop at output voltage at you can get only the limited output at the voltages. So this is a slide to explain what is the interelectrode capacitance, what is a CGK, CGC, CPK, and interelectrode capacitance with the plate, cathode, and control gate. And next slide will make you that how the effect of lead inductance at higher frequencies, which is existing in conventional tubes. And third point explains what is the transit time. Here the transit time is the time taken for the electron to move from cathode to grid to anode. So if the frequency is more, the traveling speed of electron is very, very slow. The frequency of the signal is gigahertz of frequency, but the speed or velocity of electron is very, very slow. This will make that a cloud existing in between the plates, that is called as a transit time effect. Here is a relation between transit time and distance and velocity. Here the distance between the plates are very, very narrow. Therefore, the velocity is the transit time is very, very less, but it is velocity is very, very more, and that is not matched with the high frequencies. Why? Because the high frequency signal frequency is very, very high. The transit time, movement of electron is very, very low. The velocity is very, very low. These two will mismatch and gives you the cloud effect at the in between the plates and grid and cathode.